When we look around us, we see many things like plants, animals, land, water, and more. They are of different shapes and sizes. Some are living while others are non-living. Some are natural while others are man-made. All these things are part of our environment. But what makes up plants and animals? What makes up land and water? The answer to all these questions is matter. Everything we can think of is made up of matter. Matter is not only what we can see or touch, but includes the air we breathe, the sun, stars, and planets. Anything that has mass and occupies space is called matter. If you hold a book, you can feel its mass. When a balloon is inflated, its size increases. Matter can also be perceived by our senses. We can feel its presence, especially when wind blows. Matter offers resistance too. If you try to swim against fast-flowing water, you'll find it difficult. All substances, whether living or non-living, are composed of matter. Living type, plants and animals. Plant examples include lotus, banyan tree. Animal examples include dog, cat, humans. Animals can be natural or man-made. Natural examples include air, water, stars and rocks. Man-made examples include artificial plastic, cement and nylon. Creation of matter. Most scientists believe that all the matter in the universe was created in an explosion called the Big Bang. This explosion released a large amount of energy. Then, after just a few seconds, some bundles of energy turned into tiny particles of matter. Living matter. Earth is home to all kinds of plants and animals. They can grow, move, and reproduce on their own. Non-living matter. Most of the matter in the universe are non-living. They do not grow, move, or reproduce on their own. They can be natural or man-made. Natural matter, they occur in nature and can be used to make more useful substances. Example, wood, coal, silk. Man-made matter. They are produced artificially from natural matter, e.g. plastics, soaps, detergents, medicines. Does matter of only one kind exist? No, there are different kinds of matter. Different substances or materials are made up of different kinds of matter. Like chair is made up of wood, bucket is made up of plastic. From the above, it is clear that there are different kinds of matter with different properties. Matter has mass. The amount of matter in an object is called its mass. The larger an object, the greater will be its mass. Matter occupies space. The space occupied by matter is called its volume. The greater the size of an object, the larger will be the space occupied by it. Matter is something that we can see, touch, taste, smell, or feel. Now you know that all substances are made up of matter. But what is matter made of? Matter is made up of extremely small particles called atoms. An atom is the smallest possible unit of matter that exhibits all the properties of matter. Atoms really do not have an independent existence. Therefore, they combine with one another. Two or more atoms combine together to form a particle called a molecule. A molecule is the smallest unit of matter, which exhibits properties of that kind of matter. However, atoms and molecules are so small that they cannot be seen through the naked eye or with an ordinary microscope. A molecule can be formed of atoms of one kind or different kinds. Example: a molecule of oxygen is made up of 2 atoms of oxygen. A water molecule is made up of 2 atoms of hydrogen and 1 atom of oxygen. In ancient times, it was thought all kinds of matter were made up of earth, air, and fire. Later, it was the Indian philosophers and John Dalton who proposed that all forms of matter are made of atoms. Properties of matter can be explained on the basis of the following characteristics of particles. Particles of matter are held together by a force of attraction that exists between them. The force is known as intermolecular force of attraction. It's different for different kinds of particles. Particles of matter are always in random motion because they possess kinetic energy. It increases with increase in temperature and vice versa. Particles of matter have space between them known as interparticle or intermolecular space. This is due to the random motion of particles, which sometimes brings them close and sometimes keeps them apart. Intermolecular gaps between the molecules can further be shown by the following activities.
Now, you know that all substances are made up of matter. But what is matter made of? Matter is made up of extremely small particles called atoms. An atom is the smallest possible unit of matter that exhibits all the properties of matter. Atoms usually do not have an independent existence, therefore, they combine with one another. Two or more atoms combine together to form a minute particle called a molecule. A molecule is the smallest unit of matter which exhibits all the properties of that kind of matter. However, atoms and molecules are so small that they cannot be seen with the naked eye or even with an ordinary microscope. A molecule can be formed of atoms of one kind or different kinds. A molecule of oxygen is made up of 2 atoms of oxygen. A water molecule is made up of 2 atoms of hydrogen and 1 atom of oxygen. In ancient times, it was thought that all matter was made up of air, water, earth, sky, and fire. Later on, it was Maharishi Kanada and then John Dalton who proposed that all forms of matter are made of atoms. Properties of matter can be explained on the basis of the following characteristics of its particles. Particles of matter are held together by a force of attraction known as intermolecular force. Particles of matter are always in random motion because they possess kinetic energy. This energy increases with an increase in temperature and decreases with a fall in temperature. Particles of matter have space between them, called intermolecular space. Random motion sometimes brings them close to each other and sometimes keeps them apart. Intermolecular gaps between the molecules can further be shown by the following activities.
Matter exists in 3 different states: solid, liquid, gas. Intermolecular force of attraction and intermolecular space are 2 important properties of matter. If the intermolecular force increases, molecules come closer, decreasing intermolecular space. If the intermolecular force decreases, molecules move away, increasing intermolecular space. This fact accounts for the different states of matter. A solid has a definite shape and volume. Molecules are packed close together. Solids are rigid, retain their shape, and are almost incompressible. Examples of solids include wood, stone, iron, and gold. The effective pressure on solids also depends on their type, hard or soft. Hard solids retain their shape. You can't cut metal with a knife. Soft solids can be easily cut or stretched with force, like rubber bands. A liquid has a definite volume, but no definite shape. It takes the shape of its container. Liquids flow from higher to lower levels and have one free surface. Examples of liquids include water, milk, and petrol. Liquids have low density and can diffuse slowly. A gas has neither a definite shape nor a definite volume. Gases have no definite volume. They can be compressed inside a small container and can also spread into a large space area, if available. They do not have any definite shape. They completely occupy the space in which they are kept. For example, Air, when pumped into a football, takes the shape of the football. They can flow and move in any direction. Gases exert equal pressure in all directions. They do not have any free surface. They have very low density. They can diffuse very fast. For example, the fragrance of an incense stick spreads into the whole room rapidly because of the gas coming out of it. Examples: hydrogen, nitrogen, oxygen, carbon dioxide, sulfur dioxide, etc. Air is a mixture of gases. In solids, the molecules are closely packed. There is a strong force of attraction between the molecules. The molecules are, therefore, not free to move. They merely vibrate about their mean positions. This makes solids hard and difficult to compress. In the case of liquids, the molecules are not very closely packed. They do not attract each other as strongly as the molecules of solids. Molecules lie nearly apart from each other, with a great force of attraction between them. Molecules lie very far from each other, with very little force of attraction between them. The position of molecules in the solid, liquid, and gaseous states. Solids have close intermolecular spaces, allowing limited movement. Liquids flow and take the shape of containers having fixed volume. In gases, molecules are far apart, allowing great freedom of movement. Gases fill available space and can be easily compressed. Differences in states of matter are due to intermolecular forces. Cohesive force holds together, like particles, in substances. Brownian movement is the zigzag motion of particles in a medium. In liquids and gases, weak cohesive forces allow random particle movement. Since particles of matter are in motion, they can mix through natural movement. The phenomenon of intermixing of particles is called diffusion. Gases diffuse very fast, as particles have space to move freely. Liquids diffuse slower than gases. Not all liquids mix. Miscible liquids, like water and alcohol, mix well. Immiscible liquids, like water and oil, do not mix. When a substance is heated, it can cause change, interconversion in states of matter, thermal expansion of the matter, chemical change. For example, when water is cooled, it turns into ice. When we heat water, it starts boiling and turns into steam. Steam, on cooling down, turns into liquid water. Ice, when kept at room temperature, melts back into water. The chemical properties of water remain the same in all three states. One of the best examples of interconversion of matter is the natural water cycle. Due to the heat of the sun, water evaporates and moves up in the atmosphere. Water vapor condenses and forms clouds containing tiny droplets of water. When these droplets become bigger, they fall down as rain. This phenomenon is never ending. The water cycle balances water on Earth and also controls the climatic conditions of our surroundings. This shows that matter can change from one state to another. The process by which matter changes from one state to another and back is called interconversion of states of matter. Since no new substance is formed, the interconversion of states of matter is a physical change. The change in the states of matter is caused by change in temperature and by applying pressure. When temperature changes, matter changes its state. Pressure is also one of the important factors for the change in the state of matter. Most substances change their state when conditions are changed. Solid changes into liquid which further changes into gas when temperature is increased. Gas changes into liquid, which further changes into solid when temperature is decreased. Gases change into liquid when pressure is increased and temperature is decreased. LPG cylinders contain cooking gas in liquid state at high pressure. Under normal conditions, LPG is a gas. Oxygen cylinders used in hospitals contain oxygen in liquid form under high pressure. Solids can change into liquid state under high pressure and temperature. Even the hardest rocks under the Earth's crust melt at a very high temperature and pressure to form magma. The change of state is a reversible change affected by temperature and pressure. Some substances change from solid to gas directly, for example, camphor, iodine, and dry ice. These are called sublimable substances. Sublimation is the conversion of a solid into vapor without becoming liquid. Naphthalene balls used in bathrooms and wardrobes keep pests away and are sublimable substances. Naphthalene balls with woolen clothes get smaller over time as they sublime and disappear. Do all substances change their state? No, not all do. Melting or fusion is when a solid changes to a liquid on heating due to energy gained by particles. At melting point, the temperature stays constant as the solid converts to a liquid. Different substances have different melting points in their pure state. Example: melting point of ice is 0 degrees Celsius. Vaporization: the process by which a substance changes from a liquid to vapor on heating is called vaporization or boiling. As a liquid is heated, its particles gain energy and move more vigorously, increasing gaps between them. Ultimately, a liquid changes into gaseous state. Boiling point: the fixed temperature at which a liquid changes into gas is called its boiling point. The temperature remains constant till the whole of the liquid changes into gaseous state. For example, the temperature of water remains 100 degrees Celsius till all the boiling water converts to steam at normal pressure. Evaporation: the change of state of a liquid into vapor below boiling point is evaporation. Evaporation occurs even at room temperature, but speeds up with heating. You know, wet ink dries because water in it turns to vapor and evaporates. Similarly, a cut fruit left exposed to air dries up in a short time. We spread wet clothes under the sun to dry them fast. Condensation or liquefaction: the process by which a substance in gaseous state changes into its liquid state is called condensation or liquefaction. This process occurs when a gas is cooled. On cooling, the energy of particles decreases. The gaps between the particles decrease and the force of attraction between them increases. As a result, they change from gas to liquid. Condensation point: it is the temperature at which a gas starts changing into its liquid state. Example: condensation point of steam is 100 degrees Celsius. Freezing or solidification: the process by which a substance in liquid state changes into a solid state is called freezing or solidification. This occurs when a liquid is cooled because on cooling, the particles lose energy. They then come closer, decreasing the intermolecular space and increasing the intermolecular force of attraction. Freezing point: the temperature at which a liquid starts changing into its solid state is called its freezing point. Note: conversion of a solid to liquid on heating is called melting or fusion. Melting: solid plus heat. Liquid on cooling liquid freezes into solid. Freezing. Liquid, heat, solid. The fixed temperature at which a solid melts to liquid is called its melting point. The fixed temperature at which a liquid boils into its vapor state is called its boiling point. Melting and boiling points depend upon the nature of the substance. Conversion of a liquid into vapor on heating is called vaporization, boiling. On cooling, vapors get converted into liquid and is called condensation. Thus, we can say that the change of state is a reversible change affected by temperature and pressure. All the three states of matter, i.e. solid, liquid, and gas, expand on heating. This process is called thermal expansion. When cooled, the substance contracts again. This can be shown by the following activities. Do you know the thermometer is constructed on the principle that a liquid expands on heating and contracts on cooling? The mercury filled in the thermometer expands with increasing temperature and contracts on cooling, i.e. decreasing temperature. Different substances expand at different rates. Thermal expansion is also a physical change, as it is temporary and reversible. A chemical change is a permanent change, in which new substances are formed from the substances taken. The properties of the new substances are entirely different from those of the original substances. Heating causes chemical change in a substance. This can be shown by the following activity. Some more examples of chemical changes brought about by heating are burning of wood and cooking food. Wood changes into ash, and raw substances cannot be recovered from cooked food. A chemical change is permanent and irreversible. An example showing both physical and chemical changes is burning of a candle. When a candle is lit, first, candle wax melts, then turns into vapor. The vapors react with air to produce carbon dioxide and water. A candle on burning becomes smaller and smaller, and the wax undergoing chemical change cannot be recovered. Points to remember. Gradual mixing of substances by molecular motion is called diffusion. The freezing point of water is 0 degrees Celsius, and the melting point of ice is also 0 degrees Celsius. The boiling point of water is 100 degrees Celsius, and the condensation point of steam is also 100 degrees Celsius. Substances in the gaseous state under normal conditions are called gases. Water changes into a gaseous state on heating, hence it's called water vapor. A substance in pure state has a fixed boiling or melting point for purity testing.